Hi, in this video I'll teach you how to use the Box Struct in RhinoCommon. So again, after heading to the RhinoCommon API website, under Rhino.geometry namespace we'll have to deal with the Box Struct in here. And as any other class or structure, we find that it's under a certain namespace, which is Rhino.geometry, and it's not inherited from anything else. So it's a standalone struct. It's not inherited. It does not inherit to any other class even. We can construct a box using a bounding box, using another box, so it's actually copying a box, or using a plane, a bounding box, a plane, and geometry-based geometry, a plane, and some points. So in this case, it will take the smallest box that contains all of the points added, or using a plane and intervals in the X, Y, and Z. So it's the size of the box actually. And we've seen the interval, but we never seen the plane geometry, so we'll need to check it quickly before getting to construct a box, and we'll find it under geometry here. So if we find a plane here, we can construct a plane using the equation ax plus by plus cz plus d. So you'll need to add the a, b, c, and d, using another plane, using a point, an x point and y point, a point and a vector with a vector direction, or an origin and a vector normal. So a lot of ways to construct a plane, but in the properties part of the plane we'll find some very interesting properties, like the world xi, world yz, and world zx, exactly like in the vectors, which are treated actually exactly the same as the points. The vectors have properties like the z-axis, the y-axis, and the x-axis. So if I want a unit z vector, all I have to do is vector3d dot z-axis. If I want a unit x, I will say vector3d dot x-axis, and so on. And the same with the plane. So if I want the xy plane, I only have to write plane dot world xi. And if I want to find the origin of a plane, I'll write the plane's name dot origin to get its origin, and so on and so forth. Again, back to the box. Here, let's try heading to Rhino and create some boxes. Let's remove this one, these points we created before, and let's add a C# script here. And let's try first with the box that is created to include a set of points. So the smallest box that is included, that includes a set of points. So if we move these points up, if we take this one exactly and move it to make it the highest and move this to be the lowest, then we're expecting a box that goes in the y-axis from this point to this point, if we see in the top view, from this point to this point, and on the x-axis it shall go from this point to this point, and on the z-axis it shall go from this point to this point. Let's try this. So what does it require from us? It requires an enumerable of point3d, so a list of point3d and a base plane. That's it. Let's add our points here. So we'll add multiple points and we'll connect it to the x and call it PTS. Don't forget to make it a list axis and to make it a point3d type. Now let's create our box. So as a struct, we'll have to write the struct's name, give it a name, box A equals a new box, and here we'll add at first our plane, which we learned that could be written like plane.world xy, and instead of intervals we need our list of points, and that's it. If you write a equals box a, then if we run this script it will create exactly what we thought about. If we go to the top view to check, it starts from this point to this point and from this one to this one. If we go from the front, it goes from this point to this point. So it's the smallest box that can contain all the list of points. And if we move, it will of course change here. If we move this point here, if we move this one here, we can change our box freely. So what is the other common way to create a box? The other common way is to use intervals with a plane, of course. So we'll start with our plane, and we need intervals in the x, y, and z. So we can directly write here new interval from 0 to 10, and this will be the x interval, and then add another interval here and another interval here, and in this case it will create a box that goes from 0 to 10 in the x-axis, from 0 to 10 in the y-axis, and from 0 to 10 in the z-axis. If we run this, this is what happens exactly. And if we want to play a bit with it, we can just add as many inputs as we want here. So let's not change them to save our time, but here if this is y, this is let's say this is y, this is x, this is z, this is u, this is v, and this is w. And let's make these doubles. Now we can have better, much better control of our component. Of course, here all the values are 0 in default, so it does not change. But if we say we don't need the points anymore, if we say from 0 to 10 and copy it 6 times, okay, here 1, 2, 3, delete this one, 4, 5, and 6, and here let's just make it more appealing. We'll add this to the y, x, z, u, v, w, and now we can start creating a box, our box in the x, y, and z. So here it starts in the x from 3 to 6, and it takes exactly 3 units. Here it goes from, let's say, 2 to 6 instead, to get a better understanding. So it starts with 2 units on the y axis and extends to 6, and here from 0 to 7, and now you can really control your box as you want. If you want to start it, let's make a box with a center at the 0. In this case we can go from -2, okay, to 2, and let's copy these now. So now this box will have a center exactly at the origin, and if you want it to start from the 0, we can just create it like this. So we can control easily our intervals. And now let's go and see some of the properties. We can get the area and the center of the box. We can get the bounding box, which is the box actually. We can get its volume, and in this case we can just try b equals box a dot volume. Okay, we'll check if we need to write the brackets or no. Well, let's try this. Yeah, and we don't need to write the brackets actually. And here it's 64 as volume. If you want to check the area, it should be 16. Oh, the area of the box. Okay, it's 16 multiplied by 6, right? So sorry, let me check this. I need to make sure that it means the area of the sum of those of all the faces. So 6 by 16 is actually 96. So the area means the sum of the areas of every face. So 16 by 6 equals 96, and we can get the interval at x. So if I want to learn what is the length of this box, I can just write box a dot x, and as methods we can check if the box contains another box or not, if it contains a point 3D or not. We can get the closest point to the box, we can get its corners, and this gives me an array. So let's try this. This is really interesting, and here we work with arrays. So it returns an array of point 3D. So let's say I want to get exactly this point. What can I do? It's not a static method, I think, so we can use the box A, and here we can say point 3D array, let's call it corners, equals box A dot get corners. And then if I want to get a certain corner, and I'm expecting how many? 4 and 4. I'm expecting 8 corners, of course. And in this case, if I want to get the corner here, it will be C equals corners, and we'll give it the index. So if we add here C, we can get the point at the corner. And we have an error here. Let's check it. It says, yeah, get corners needs to have empty brackets, I think. Yep. And here we could get this point, and if we change it, it will give us the next point, which is here. We can get this point, we can get the 8th point, or the last, oh, the 7th point, I'm sorry. So we're starting from index 0 to 7, and this gives us 8 points, and this will be our last point. So really interesting. We learned here how we can get a point and how to read that. Get corners gives us an array instead of a list, and we can get a point at the box. We can turn a box to a B-rep, we can turn it to an extrusion, or we can transform it, and so on and so forth. I hope this video was interesting to you, and I hope you've learned something useful. Let's meet in the next video. Thank you. Kindly like the video and subscribe to our channel.